And why am I calling this tough? Let me first explain to you guys why I'm calling this a tough day. It's going to be a tough day because your chart is useless. The last two types of graphs we've done, you've been able to just plug in your calculator, write the point in the chart, plot it, connect them as we go along. That's not going to happen for this one, unfortunately. You can if you want, but it's not going to get you anywhere that's going to be useful. It's going to get you more confused. Before we start, let me go over the two graphs we've done already and how this one is different. First, we did r equals 4 sine theta. Anybody want to describe to me what that graph looked like? That was a what? Anything with a number and just sine or cosine was just what type of graph? A circle, right? That was just a circle. All right, that was just a circle with the number and sine and cosine. I know it's going to come out to be a circle. I can use my chart. All right, and then the last 2 days we did something with a minus and a plus sign. So if I have 1 minus 4 sine theta, I don't need you guys to know the official name of it, a lima san, but it looks like a heart. Okay, looks like a heart. Both of those graphs, you can use your table for, plot the points, connect them. No big deal. Now take a look at what we're doing today. R equals 4, and I'm just copying number 1, sine 2 theta. All I need, guys, very simple question to all of you. What is different about that versus the other two? Where do you see a new number now that we never have before?
4 theta.
Before?
Yep. Yeah. Yep, before the theta. Everyone sees that. We finally see a number before theta. All right, this is where you got to be disciplined and say, all right, I can't fill out my table. It's not going to get me anywhere when I see a number in front of theta. So what I want you to do first is go to Desmos. Let's see what this bad boy looks like. Let's give it a name. All right, so everyone go to Desmos, polar graph, type in r equals 4 sine 2 theta. So you can see what we're about to graph. Make sure you type in the word theta, T-H-E-T-A. Oh, look at that, huh? Look at that beaut. How beautiful is that? Okay, we call this a petal graph. This is a petal curve. All right, petals. So anytime I see a number other than 1 in front of the theta, we're going to have some petals. But you guys got to remember some rules now. All right, again, your table will not help you out in a petal graph. It will not. All right, so let's start. All right, let's start with some rules about a petal curve. First, I'll show you how long is each petal. You guys go back to Desmos. Go ahead, go back to Desmos for me. Look at each petal right now. How far out does it go? How many circles? How far out? 4? Everyone agrees it goes out to 4? That's the furthest it goes. And look at your equation. This first number right here, everyone, this first number will tell you the length of each petal. Okay, that will tell you the length of each petal. So we will go no further than 4 now. All right, next question. How many petals are on this graph? 4. So do I get it from the same spot? No. No. Ready? This number right here, next to the theta, will tell you how many petals there are. Well, wait a second. Wait. You said there was 4 and there's a 2 there. All right, ready for your first rule. Ready for the first rule you got to remember. If this number is even, if that's an even number, I double it and that'll tell me how many petals I have. Okay? So the if even number of petals equals 2 times that number. So does everyone see where we're getting 4 petals on your curve now? Well, Mr. Carlino, what if it's odd? Great question, because you're going to get an odd number there. So here you go. If it's odd, that's the number of petals. Done. You don't have to double it. If that number next to theta is odd, that's how many petals you're going to have. All right. So first rule you got to remember there. How many petals is determined by the number next to theta. Even, double it. If it's odd, you already have the number of petals. Questions right now on how long each one is and then to figure out how many, because there's a couple more rules, believe it or not. Any questions, guys? All right, next thing, go back to Desmos graph. Go back to the Desmos graph. You can't tell right now, but each petal is a certain amount of degrees apart. Go back to mine. Each petal is a certain degree amount apart. Right? Does everyone see that? It's a certain amount of degrees apart, each of the petals. How do I figure out how many degrees apart each petal is? Ready? If you go all the way around, it's 360. We know that. If I go all the way around the grid, it's 360. Those petals are evenly spaced out. How many petals were there? 4. So go all the way around and divide it evenly by the 4 petals. Each petal is going to be 90 degrees apart. Okay? Each petal will be 90 degrees apart. I don't care what, even or odd, doesn't matter. 360 all the way around divided by how many petals will tell you how far apart they are. All right. Last thing is, where do I start the first? I know there's 4. There's going to be 4 petals 90 degrees apart. How do I figure out where to graph the first one? How do I figure out how to graph the first one? And I know I'm really bringing it today, but hey, this unit hasn't been that bad, let's be honest. Where you graph the first petal is determined if this is a sine or a cosine graph. Okay? That's where the first petal will be graphed. Determines if it's sine or cosine. So if it's sine, you go halfway. So each petal is 90 degrees apart. So the first petal will be half of that, 45 degrees. So you take how far apart they are divided by 2, and that'll show you where the first petal is. What if it's cosine? I'll talk about that when we get to the next curve. I've already filled your brain with enough. But man, watch how easy this graph's going to be if we know the rules. All right, here we go. Now, first problem you run into, the graph is in radians, right? Okay, if I want to go to 45 degrees, anybody remember way back on day 1 in degrees what each marking goes by? On the polar grid, each marking goes by what? In degrees. 15 degrees. Okay, so everyone find 45 degrees now. Everyone find where 45 is. So you got 0, 15. Don't forget, I did this second period. Don't forget about the ones that are unmarked. All right, 15, 30. Everyone see where 45 degrees is, right at pi over 4? Here's where we're going to build our first petal, and this is going to be easy. How long are these petals? What's the length of each petal? Now I'm going to start calling on you guys. What's the length of each petal here? 7. Here we go. Will, what did we say was the length of each petal?
4.
4. So guys, at 45 degrees, you graph 4. That's where the first petal is going to be. So at 45 degrees, 1, 2, 3, you go out to 4. Second thing, because I don't know how skinny or how wide this could be. It could look like that. I don't know. Could be a little bit wider than that, right? I don't know how wide or how skinny this is. So what I'd like you to do now is to the left and to the right of 45 degrees, find those points. To the left and to the right. So let's go to the left first. Pi over 3. Pi over 3. So everyone take pi over 3 and plug it in and let me know what you get for an R value. And I'll show you something pretty great here. When you plug in pi over 3 in the equation, what's your R value? This is something we've been doing all unit. Nothing crazy here. Oh. Dan, when you get the value, let me know. 4 sine 2 times pi over 3. Let me know what that R value comes out to be into the nearest tenth.
I got 3.5.
Yep, 3.5. So everyone ready? To the left of 45 degrees, you'll graph 3.5. And if you've already gone ahead and done pi over 6, you'll also notice it's 3.5. It's the same. And that will happen every time. Whatever value to the left, it'll match the value to the right. So 3.5 to the left, 3.5 to the right. These petals always come from the origin, the center. Now you kind of know how wide or how skinny it should be. There's your first petal. Goes out to 4, 3.5 on each side. And I hate to break it to you, but we're basically done. All right, we're basically done from here. All right, where's our second petal going to be? Well, we said how far apart are they? Each petal's how far apart? 8. Colin, how far apart are the petals?
90 degrees.
90 degrees. So, hey, guys, we're at 45. Add 90. That'll tell you where the next petal is going to start. I'll write it. I don't need to see this. I'm just writing it down for you guys. So the second petal is going to be at 945 plus another 90. So wherever 135 is, that's where our second petal is going to start. So you just got to find where 135 is. We know 90 is on top. Again, guys, I know it's not labeled with a radian, but you still got to count it. Make sure every single marking is 15 degrees. 120. Are we all at 3 pi over 4? All right, go out to 4. At 3 pi over 4, 135 degrees. Everyone go out to 4. 1, 2, 3, 4. And you can put your calculator down because you already know what's to the right and to the left. That's the same. That's not going to change. It's awesome. It's not going to change. It's going to be 3.5 to each side again. Once you do it for the first petal, you're good for all of them. So 3.5, 3.5 on each side. If you use your table for these, you're not going to get 4. Your table will never give you 4. It'll just give you 3.5, 3.5, 3.5s, and zeros. And I don't know how you're going to graph that. All right, 2 down, 2 to go. Third petal, where should it be? Where should our third petal be now? Where should I start it? Caroline, where should I start the third petal?
5 pi over 4.
Okay, well, in degrees here, go degree 135 plus 90.
Yeah.
So 225. Yep.
Yeah.
So you guys got to find where 225 is. And Caroline said it was at 5 pi over 4. Yep, that's correct. So same thing. Go out to 4, 3.5 on each side. 1, 2, 3, 4. 3.5 on each side. And then finally, we got one more pedal here, kiddos. Fourth pedal. Fourth and final one. Where should this one be? Where should our fourth pedal be now, based on what we know? Nah, dude, we got a new schedule today. Karma for me. Will, going back to you, where's our fourth pedal at? How many degrees?
$3.15.
Good job. There we go. So everyone go to 315. Where's 315 at, huh? That's 270, 285, 3 hundo, 315, 7 pi over 4. One, two, three, 4. 3.5, 3.5. There it is. It's pretty darn good. Should match yours too. You go to your Desmos graph. Any questions? Because I do want to show you something new. Not new, but it's always been there. I just want to bring your attention to it. Any questions on this curve here? Okay, on your Desmos, and this might help you out a lot with these curves. If you go back up to the wrench in the top right, everyone knows how to get the polar grid, I hope. But you see down at the bottom, you have a choice if you want that grid to be in radians or if you want it to be in degrees. It's up to you. So it might help for these pedal graphs to be in degrees. So maybe if you're having trouble, see this first one starts between 30 and 60, halfway in between 45. All right, so if that helps you, go right ahead. All right, guys? So last review here before we get to the last one. The first number will tell you how long each pedal is. The number in front of theta, if it's even, you double it, that's how many pedals you have. If it's odd, you stay with it, that's how many you have. 360 divided by the number of pedals tells you how far apart they are. And finally, if it's a sine curve, you start halfway in between that number. Now, what if it's cosine? Where do I start if it's cosine? Here we go, graph number 2. Notice I just gave you a blank table. It's not even needed. You can fill in whatever you need to find. All right, let's use some of our rules now. How long is each pedal going to be here in this curve? How long is each pedal? Look at the equation. Look what number you should be looking at. How long is each pedal here? 1, 3. Nope. Let's try again. And one more time. Will, last question for you today, Will. Looking just at the equation, Will, how long should each pedal be?
4, sorry.
Yep, 4. Each one should be 4. So the length is 4 of each one. All right, next one. How many pedals should I have? Going nuts here, Nick. Okay. Ella, how many pedals should I have? 3 pedals. Notice, hey, this is odd now. That number's odd, so that's how many pedals I have. So 3 pedals, each having a length of 4. How far apart should they be? I know I have 3 of them. How far apart should they be now? Hunter, how far apart should they be?
$120.
Yep, 120 degrees. All right, now here's the final rule. If this was sine, I'd start my first pedal at 60. We all in agreement. If this was sine, I'd start my first pedal at 60. I'm very easy, last rule. If it's cosine, first one starts at 0. Done. Done. If it's cosine, first one always starts at 0. First pedal at 0. All right? Sine is the only one you got to worry about that you have to go halfway in between. All right, let's do it, guys. Let's do it. So we know our first one's at 0. It's going to go out to 4 because that was the length. Will told us that was the length. So 1, 2, 3, 4 at 0. All right, I need to determine how wide or how narrow they are. So I need to check the value to the left or to the right. They're both going to be the same. Ooh, it's blank there. Anybody remember in radians what we go by? I know 15 degrees, so I guess you could be in degree mode. Anybody, if I'm in, my calculator's already in radian mode though. Anybody remember what we go by each marking?
Pi over 4.
Ooh, pi over 4 is up here, so not pi over 4.
Oh.
Pi over...
2.
No, that's up here.
The pi over 12.
Pi over 12. 12, yep. So everyone in their calculator, go ahead. 4 cosine 3 times pi over 12. So the only thing really I'm going to put in my table is what's the value at pi over 12? All right, what are you getting for pi over 12? Nearest 10th, pi over 12. Liz, what are you getting for pi over 12 when you plug it in?
Is it 3.9?
I did not get 3.9.
No, 11.6.
Ooh, that's a little bit too high. You're in radians?
Yeah.
Okay, so 4 cosine button, and then in your parenthesis 3 times pi over 12 as a fraction.
Wait, how do you do it?
All right, so you got your type the number 4 and then the cosine button. And then inside the parenthesis that your calculator gives you 3 times, in this case, pi over 12. And make sure the pi over 12 is as a fraction in your fraction template.
$2.8.
There you go, we're good, 2.8. All right, so everyone to the left and to the right of 0, I go to 2.8. 1, 2.8. 0.8, and there you go. There's your first pedal. Hunter already told us how many degrees apart they are, so the next one should be at 120. 0 plus 120 is 120, so figure out where 120 is on your grid. Go by 15 degrees if you have to. Top one's 90. Where's 120? So everyone at 2 pi over 3, you're at 120. And we go to 4 again. Right and left, 2.8. I'll just keep writing where the pedals are. All right, last question for somebody. Where's the third pedal going to be? Because there's only 3. I've already graphed 2. Where's the third and final pedal going to be? How many degrees? It's just one of those things, Nick, you know, and then I can't call on Will anymore. Hunter, going back to you. Where's our last pedal? How many degrees?
120.
Well, that was our second one. Go another 120 now. This is our last one, our third one. Our second one was at 120. Where's our last one going to be?
4 pi over 3.
Yep, 240. Good. Which is down at 4 pi over 3. There it is. Just got to remember the rules, and I know that you can use Desmos if you need to. Questions, anything? What's up, Nick?
Do you need to write in the table at all? Like, is that
The only thing I'd like to see in the table is that one value to either the right or to the left of the maximum that you're going to do. I would like to see at least that value. Yes. All right, you guys, if you didn't hear Nick's question, it was a very good one. He said, hey, do I even need to write anything in the table for these curves? And I said, yes. I at least want you to write in the value to the left or to the right of the maximum that you're testing. At least that. Because I know most of you guys might just go to Desmos and copy everything. So this shows me that you at least have some sense of what's going on. So at least one value in your table, please, either to the right or to the left of the maximum. All right, we'll work on this Monday, Tuesday review, Wednesday quiz 3, and we're done with the unit. Nothing stronger than ginger ale this weekend. Be smart, be safe. See you guys on Monday.